Alright, so let's check out what the question is. The question reads, determine the potential difference between point A and B. And then based on this concept, they have some other variations in which they can ask the question. So we'll just go through those details through those variations as well. But let us start off with this one. What we need to find is we need to find the potential difference between this point called point A and this point known as point B. So we need to find potential difference between these two. How do we do that? We find the potentials at A and B, and then we take a difference of it. So the potential difference between A and B would be the electric potential at A and electric potential at B and difference of it. And when I say the word difference, I mean we forget about if we get the negative sign in the answer. We just going to look at the magnitude. And how do we write that thing in mathematics? We say we're going to consider the absolute value only. So if the answer is, let's say, -3, we're not going to write -3, we're going to write 3. We're just going to write absolute value. So it doesn't matter which one is the bigger voltage. You just have to subtract the two voltages and forget about the sign because you don't have to write the negative sign. Now the first question is, how do we find the voltage at A? Whatever method we choose, then we can use the same method and we can then find the voltage at B. But let's break it down into steps, and we want to find the potential at the point A. Let me draw the pathway for the current. In the first loop, I can say the current flows through the first loop something like this. So you can just think about it as a power supply. Just replace it with a battery of 10 volts, and then you have two resistors. The first one is 550 ohms and the second one is 950 ohm. Okay, just I've simplified the circuit for you. So forget about the upper one, think about the lower circuit, and you need to find the voltage at this point A. And the total voltage was 10 volts. And before you do that, the voltage at A, this voltage VA, would equal to the voltage that has been dissipated across this resistor after you subtract them from the total voltage. So what I'm saying is, as you can see, the total voltage is 10 volts. And let's say across this resistor, some of the voltage has been dropped. Some of the voltage has been lost across this resistor. Whatever that voltage is, the leftover or the remaining from 10 would be the voltage at A, or would be the potential at A. So let's say if across the first one, the loss of the voltage is, or the potential difference across the first resistor is 3 volts. Now what is the leftover? 10 minus 3, i.e. 7. So 7 volts would be the voltage at A. And then you can say, the more perceptive of you would be tempted to say, why don't we simply find the voltage across the 950 ohm resistor instead of first finding the voltage across 550 and then subtracting it from 10? So why don't we simply find the voltage across 950 ohm? And the answer is you can. And matter of fact, you should. So whatever the voltage is across 950, in this case, okay, in this case the resistor would be 950. So voltage at A equals, just let me write over here, equals, a very important step, you can just note it down, equals the potential difference across 950 ohm resistor. You can call it R2 if you want, but the voltage at A, or the potential at A, equals the potential difference across 950 ohm resistor. And the other method I've told you already, you can do it this way as well. The voltage at A equals 10 minus potential difference across 550 ohm resistor. So whatever method you're comfortable with. Find the voltage across, I'll say just find the voltage across this one, and that would be the potential at A. Now the big question is, we have stated this thing, that whatever the voltage across 950 ohm resistor would be, that would be the potential at A. But the big question is, how do we find the voltage across 950 ohm resistor? And for that, just consider the same circuit that I've drawn over here, the simplest form. This is 10 volt power supply. Here you have first resistor, which is 550, and then you have the second one, which is 950. That would equal the voltage at the point A. Instead of coming through this side, finding the voltage across this one, and then subtracting it from 10, just simplify the leftover voltage. In the simplest circuit, in the second circuit, how do you find the voltage across 950? We can use potential divider formula. So you see, there are plenty of methods to answer this question, and no method is right or wrong unless you're getting the same answer, unless the mathematics is right, the concept is right. There are plenty of ways you can approach the question. First, we can find the total current passing through the circuit, and the same current would be passing through this one, the same current would be passing through this one, and in order to find the voltage across this resistor, we can then use the formula V equals to IR. We would have found the current already, and we simply multiply by the resistance 950, we can find the voltage across that one. Totally acceptable. And once again, you have potential divider formula, which is also implication of cross multiplication. So what I'm going to do is, because at this stage I have not explained the potential divider formula, so what I'm going to do is I'm going to use a ratio method. That's my favorite one, cross multiplication. Favorite one because the students find this one very convenient. So you write resistance on one side and voltage on the other side. Now the question is, this 10 volts is being supplied to what resistor? This 10 volts is being supplied to the total resistance, because the total voltage, the EMF of the battery has to compensate, has to feed all the resistors. So for the resistance, if I add both of them, I get 1500. So 1500, the voltage across 1500 ohm is 10 volts. And if you need to find the voltage across 950 ohm, that would be X volts. And then you cross multiply. Simply multiply these two. And what do you do afterwards? You get the answer. And in this case, X equals 9500. Because you multiply by 10, you get 9500 divided by 1500. And you get 6.3. That's what you get. So the potential at A is 6.3 volts. That's the potential at A. Now, using the same method, we're going to find the potential at the point B. So the potential at the point B would simply be the potential difference across this resistor. Now forget about this thing. Just forget about this branch. And what you have to do is consider this circuit. Now it would be reduced to something like this. 10 ohm EMF. Then you have the one resistor here, 350. The other one over here, which is 250 ohm. So I'm going to use the same method, cross multiplication, but for the second branch, the lower one. And I need to find the potential difference across this one now. And that would equal to the voltage at B or the potential at B. So you write R on one side, V on one side, V on the other side. And then you say the total voltage was 10, the EMF was 10, and when the total resistance was 3, 4, 5, 600, the voltage across 600 was 10 volts, and the voltage across 250 would be X volts. And then you find the answer for X, and you simply open up the calculator, just play with the fractions. So you get 2500 divided by 600. You get 4.1666. So I'm going to round it off to 2SF 4.2 volt. So the potential at B is 4.2 volts. Now, how do we find the potential difference? Doesn't get easier than that. You simply have to subtract these two. Potential at A, difference of potential at A and B, potential at B equals to the potential difference between A and B. How much is that? 6.3 minus 4.2. We open up the calculator. Whatever the answer was, minus 6.3. Because I can ignore the negative sign, I get 2.13. So we get for this question. So a very important topic and a very important concept. So let's move on to some of the sample questions. Now, before I move on to the sample question, let's do some of the commentary on this. And that thing is, let's say if the potential at A and the potential at B were equal, and there could be a chance that the potential at A and the potential at B is equal. In that case, if the potential at A equals the potential at B, then the potential difference between A and B would be 0. Because mathematically, if you subtract the same values, you'll get 0. And thereby, if there is a galvanometer here, if there is an ammeter here, galvanometer here, or for example, there is an ammeter here, then no current would be passing through that component or through that appliance, whether it be galvanometer, whether it be an ammeter, whether it be a resistor. Even if it is a resistor, no current would be flowing through the resistor, because current equals to potential difference divided by resistance. If the potential difference across that appliance is 0, no current can flow through it. And in the question, what they do is, sometimes they ask you to find the current if the current is 0 or not. So how do you do that? You find the voltage at A, you find the voltage at B. If they are same, you can simply say, since the potential at A equals the potential at B, potential difference would be 0, and hence no current would flow. Or what they can do is they can give you this thing. They can provide you with this data that there is no current flowing through the galvanometer, no current flowing through the ammeter, or no current flowing through this resistor. So you would know indirectly they are telling you that the potential at A equals the potential at B. And what they would ask you is, they might ask you to find any unknown resistance. So for example, they would just erase off this one and they will replace it with resistance R, and they'll say these two, through this resistor no current is flowing. So indirectly you know that the potential at A equals the potential at B, and they'll say find the resistance then. And matter of fact, we're going to solve that kind of question exactly underneath that. So just quickly draw the circuit diagram so I can explain this one. So before you start the question, let's see what is the important information in the question. I'm going to mark it. I'm going to highlight the important information over here. For example, the galvanometer is, the current passing through the galvanometer is 0. The reading on the galvanometer is 0. And obviously, galvanometer does not give you the reading of mass, does not give you the reading of force. It gives you the reading of current. So basically, current is 0. And let me just label this point as A and this point as B. If the reading on the galvanometer is 0, and B, the difference between A and B, and you could see it for the fact that for the first branch, for the upper loop, you can simply find the potential at A. A numeric value can be obtained. But for the lower branch, this one over here, for the lower loop, you cannot find a numeric value of the potential because one of the resistance is missing. So for the lower loop, you'll be getting an expression for the potential at B. Know what I'm saying? So for this one, you'll be getting numeric value. So I hope you get this thing. What I'm saying is, in the lower loop, you're not going to get the numeric value for the potential at B. This thing has to be understood clearly. And obviously you'll see what do we mean over here. Now, a very popular mistake, even if you think that you have done the topic and you would be able to solve the question, a very common mistake is you have to follow the direction of the conventional current. The current flows through here, and this side would be at voltage 4, plus 4, and the other one would be at 0 volt. Unlike the upper one, where the current was flowing through the left side. So this one was positive, this one was negative. It is given in the question. Either they can give you the direction of the current, or they can show you the polarity of the battery. So if this is 10 volts battery, so this side would be at voltage 10 volt and the other side would be at 0 volt. Only then you get a potential difference of 10 volt between these two ends. But for the lower one, the orientation of the battery is being changed. So in this one, first of all, just write down a pointer. I know it would be a hot potato for you, but we have to just note it down first. In this case, because the battery is reversed, the potential at A equals the potential difference across, not the resistance on the right side now, rather the resistance of on the left side. Potential difference across 9 ohm resistor. If you compare it with the previous one, we said potential at A equals the potential difference across 950 ohm. We picked up the resistor on the right side. But in this case, we are picking up the resistor on the left side. Now voltage at this point would equal the potential difference across this one. So the direction of the current has been reversed. So the current flows from here. Out of that 4 volt, the 4 volt, just assume it this way. It may not be portraying what happens in reality, but just for the sake of convenience, you can see 4 volt comes from this side, and out of that 4 volt, some of the voltage is dissipated across this one, and the leftover goes or is provided to the point A or to the resistor 9.0 ohm. But it's just the difference is because of the direction of current and because of the orientation of the battery, nothing else. So in this case, the potential difference, the potential at A equals the potential difference across 9 ohm battery, not the potential across 3 ohm resistor. So what I'm going to find is use the ratio method to find VA. So I'm going to write R here. I'm going to write volt over here. So what is the total resistance? 9 plus 3, 12. So 12 volt is getting 12 ohm is getting 4 volts, and then 9 ohm will be getting X volts. What do we do then? Nothing. We just call the calculator. Matter of fact, we don't even need it, but just I'll show you this thing. Now for the 36 divided by 12, you should be getting 3. So 3 volts you get at the point A. So the voltage at A after cross multiplication is 3 volts. So 3 volts over here. So orientation of the battery is very important. Let's find the potential at B. So I'm going to find potential at B. So I'm going to write R here, and I'm going to write V here. So you see, we're not going to get a numeric value. So the total resistance itself is an algebraic expression, 6 plus R. What do we write afterwards? In this case, another variation is, I forgot to mention the other variation. Now this loop is being fed by this battery. That's the other variation. So what should I write? 6 plus R, 9. And what do I write underneath? You see, if you follow the direction of the current, and the voltage at B would simply be the potential difference across the resistor 6 ohm. Otherwise, if you go from this side, you can totally find the potential at B from the other side also, but then you have to subtract whatever the answer of the voltage you get on this one, you have to subtract it from 9 volts in order to find the remaining voltage, or just simplify the voltage across this one, 6 ohm. So what should I write here if I want to find the potential difference across 6 ohm? 6 or R, and followed by obviously 6 would, if 6 plus R has 9 volts, then 6 would have X volts. Then you just hit it on the calculator, and could you tell me what do we get for X? Oh, sorry, not the calculator, rather we getting the expression, right? So X times 6 plus R equals to 6 times 9, which is 54. So X equals, X is the voltage at B, right? X is the unknown variable. So X equals 54 over 6 plus R. So that is the voltage at point B. Potential at point B is 54 over 6 plus R. And when I told you at the very start of the question that from the upper loop you're going to get a numeric value, which you got, which was 3 volts, which is the voltage across this one. And for the lower loop, you're going to get an expression which you have obtained over here. And if there is no current flowing through the galvanometer, means the potential at A equals the potential at B. Hence, we can say 3 volts, which was the potential at A, equals the potential at B, which is 54 over 6 plus R. We don't have a value for it, numeric value, we have the expression 6 plus R. And we will try to find the value of R from here. So 6 plus R equals to 54 divided by 3, and 6 plus R goes to 3 ones are 3 and 2, 3 eights are 24, and R equals to 18 minus 6 would be 12 ohms. So C is the right answer for this one. Here we have the next sample question, which is pretty much related to the same concepts. And matter of fact, this one is rather easier. So what we do in this one is the potential. So I'm not going to read these sentences. Everything is given in the question on the diagram. You can just see it over there. Which row in the table is correct? So question does not get, the statement does not get easier than that. Potential difference between Q and S. So you need to find potential difference between Q and S, and you need to find the potential difference between S and R and acid. So let us find the potential difference between Q and S. So let's find the potential difference between Q and S. And if you want to keep it simpler for you, you can find the potential difference across this one first. How do we do that? We see this thing, that these two resistors, if I consider this one as a single unit, there is a voltage across the first one, the one on the left side is 3 volt, the voltage across the one on the right side is 6 volt. But if I consider both of them as a single unit, and at the same time I consider the lower one as a single unit, for example, if I consider this one also as a single unit, then I can say that these two units are connected in parallel. And you cannot deny that, because this thing, if you consider it as a single unit and this one as a single unit, then these two, the left ends of these two are joined together, the right ends are also joined together, and this is how we form the parallel combination. And what is the property of the parallel combination? The most important property is voltage across the components connected in parallel remain same. Then let me ask you the question. What is the voltage across this whole loop? Not the loop, this whole, these two resistors. It is simply 3 plus 6, aka 9. So what you can say is the potential difference across that unit is 9. And since the lower one is connected in parallel with the first one, with the upper one, so the overall voltage across this one should also be 9 volts. And if from the 9 volts, if you have 5 volts over here, what is the leftover? Well, the leftover is 9 minus 5. You can count it on fingers. See, we have 4 volts. I'm going to remove everything now. So the potential difference over here between S and R would be 4 volts. Sorry. Yeah, 4 volts. Now you see, this thing is satisfied. Overall 9 volt here, 9 volt here. So this thing can be thought in this way: the first one over here, the second one over here. So the potential between across these two would be same if you consider the fact that these two are connected in parallel. Now once you have found the potential difference between these two, Q and between S and R, which is 4 volts, now you can take the difference of from any of the side and you'll get to know the voltage or the potential difference between Q and S. So for example, you can say that this one is at 6 volts and this end is at 4 volts. Now what is the difference in the potential? 6 minus 4, which is 2 volts. Or you can see from the other side as well. You can check from the other side as well. So what you can say is, if this side is, let's say, at 3 volts and the lower one is at 5 volt, and then we just subtract these two from the bigger one minus the smaller one, because we have to take the absolute value anyway. So 2 volts between Q and S and 4 volts between S and R. So A is the right answer for this, because everything in the first loop is given, but for the second one you're not going to get a numeric value. You'll just be getting an expression. You can form an expression, and what you do afterwards is you make the expression, you put the expression equal to whatever the numeric value you got from the upper loop.